Good morning, everyone. Thank you for being here. Today, we're going to talk about building security applications with generative AI. This is yet another one of the series that we're having here at SANS, addressing everything AI. We're trying to learn our way through it. Let's get through the introduction. So with me today, my name is Ahmed Abugharbia, and I work for CTW in the Managed Security Services organization. And I'm also an instructor for SANS. I teach the SEC 540, which is a class about everything cloud, DevOps, and automation. With me today, I have my dear friend, Abdul Kittana. You want to go ahead and introduce yourself?
Thanks, Ahmed. Yeah, my name is Abdul Kittana. I'm the co-founder at ASecureCloud, a company that specializes in cloud security. And recently, we've been building with AI and integrating that into our applications. And I'm excited to also share our roadmap and vision and experience of what we've been doing.
Thank you so much, Abdul, for being here. And thank you, Lara, for facilitating this webcast as well. All right. So before we begin, we're going to take you through a journey of what are the things that we have been learning about AI and building with AI. There is a specific reason why we want to do that. But let's go through how this is going to work. I will begin with a background. From there, I would take you through what are the methods and tools that we can use so that we build applications using the LLMs. I will then from there hand it over to Abdul, and he's going to share his experience with practically how is that going to happen, how does that looks like, and what are the expected results out of that. Finally, we're going to list next steps for us, and then we will also open up for questions. So the last 10 minutes are going to be for questions. Feel free to use the Q&A section in Zoom. The chat is disabled for now. So with that, let's have an introduction before we begin and talk about why exactly are we bringing this up. AI is an emerging technology, and in a way, it kind of reminds us of 10 years ago with cloud. So if you go back 10 years ago, we were at the security community, we were trying to figure out how is that going to affect the security world, right? This new thing is coming, people are moving their loads into someone else's computer. That was the term that was used. And as we learned, we started to see like how, hey, there are so many applications that you can build using cloud or based on cloud technologies, but it also is adding a lot of risk and services. And if you think about this now, in 2023, how many security applications are in fact relying on cloud, right? At the same time, we have tools that help us secure cloud, we have guides, and we have a lot of training contents specialized in cloud. It's kind of similar in here. We are still trying to understand how is AI going to affect the technology sphere that we have. For this talk, and for that reason, we would like to explore a little bit about how do we build with cloud in preparation for us to secure it. As we all know, we cannot secure what we can't understand. So to begin with, let's go through a few definitions just as a review. Oh, sorry about that. So a large language model, which is the main topic of today, is one type of AI that basically understands and can generate human-like natural language. Now, OpenAI recently created the most comprehensive and powerful series of models. So it's not one model, it's multiples. And they allow us access to these models. These are like cloud-hosted models, publicly available. And they allow us access through their APIs. So the APIs is basically what we're going to use to interact with these models programmatically, which is what we care about here. We will also talk about embeddings, and embeddings might be an interesting concept because it further helps us to make AI applications better. And it does that by creating a numeric representation of documents. What documents are those? Well, in our case, the showcase that we want to share with you is basically documentation. So enhancing the ability of the AI. We will get back to this topic. But the first and the easiest way to interact with OpenAI is by directly invoking their own applications. Let's take a look at the screenshot here. So this is a very basic function. This is available on my GitHub. You can look it up. And it basically has like few things that are interesting. So the first thing is we're using OpenAI.completion.create. So this is what we're creating a completion. We are feeding the AI some sort of a text, and it's supposed to complete it. And that could be a question, and the completion would be the answer. There are a few other things to notice here, such as the model name. So we get to choose which model we would like to utilize. And in this case, this is text-DaVinci-3. All right, sounds good. This is the easiest way. This is how we usually begin with. And to learn how to do that, that would be through the OpenAI documentation. We can go, they have like a bunch of tutorials. This is useful if we are to create an application. Maybe we would like to add logging around that application, and maybe we would like to control what data are we sending to the API. If you think about ChatGPT itself, you can consider ChatGPT to be an application that in the back end does something like this. So in the back end, it interacts with OpenAI APIs. Now, this does have the pros of being fast and easy. That's a very fast starting point. However, there are a few issues with that. And the first and major one is the cutting off time. These models do not know everything, and they will often be, at some point, they would have a cutoff in their knowledge. OpenAI GPT-3 3.5 has a cutoff at training at 2021. In addition to that, we all understand the privacy concerns that come with that. We are sending data potentially to the models that live in cloud somewhere. But then the most important one of these is that they're prone to hallucinations, which means they're not accurate. Sometimes they would come up with answers. And that might be a turn-off point, but there are ways for us to help with that. One of these ways is the ability to fine-tune the models. So fine-tuning means that we're going to take an already existing model, such as DaVinci 3, and we're going to retrain it based on a new data set. And this is something that OpenAI, as an example, allows us to do. And they allow us to do that by creating a file that we're going to call a training file. And it looks very much like the green lines in the screenshots here. So it has multiple prompts and completion, multiple examples that will be consumed by the model in the training period. And that will help us to alter the behavior of that model. So let me give you examples of that. Let's say we would like to ask the model to create an SQL query, for example. If you go to ChatGPT and say, how do I read from a table? It would give you a paragraph of instruction, etc. You would probably would like to alter that behavior so that it gives you the accurate SQL query. There's like one thing. Think about other use cases. For example, if we would like to ask a model to search the internet, right? That might be a little bit different. How about things for, if we want to ask it to create, for example, a Splunk query, but now not only we would like it to have a Splunk query, but we also would like it to fetch that data for us. This is becoming a little bit more complicated. And the way we did with that is by the third method, which is the agents. And the agents are basically these AI bots that leverage tools. And there's a lot to unpack here because this is one of the main concepts that we would like to discuss today. An AI bot would basically take a user input, and then it will create some sort of a map, a decision map, saying, hey, in order for me to get this answer, I would need the following external tools. And then I would use these tools and I would derive conclusions from them. So a good example of that would be if you ask some sort of an AI bot, who is the current president of the US? If you go and ask that question to ChatGPT, we all know that's going to be, that we will face a few issues with that, right? But then with agents, what we can do is that the agent can receive this question, who is the president of the US? And it could decide that, hey, in order for me to know this information, I probably need to do a Google search. Pretty much what we do in real life, right? This is exactly what we as humans do. That means that this agent has to have access to a tool that allows us to interact with Google, send requests to Google, search for specific data, retrieve this data back, and then make sense of it. And this is where it's really key. Let's take another example. So if we ask it, so for example, to say, hey, using Splunk, can you show me activities coming from this IP address or this specific user? So this is a very security-oriented use cases. If you think about what the AI needs to do to achieve this, well, first of all, it needs to have access to some sort of a tool that interacts with Splunk. It needs to be able to translate your human request into a Splunk query. It also needs to be able to communicate with Splunk, right? Authenticate to it and retrieve the data. And then finally, it needs to be able to make sense of this data, whatever the data is, and then give you an answer. So there are multiple steps. All of these can be achievable with things like agents and tools. Tools can be custom, so you can write your own tools as well as your own agents. And I have an example for you. So this is an example that can be found on my GitHub page. I'll share it through comments later on. This is part of a project called HackerBot. And this is a testing project, right? So nothing fancy in here. But the goal is to demonstrate what we can do with the information and knowledge and the tools that we have right now. So let me point out a few things. This was the question that resulted in this screenshot. So the question was, use CloudWatch to find an IP address that was used by the agent. And if you look at the first green line, it says a thought. I need to find out the IP address used by the agent. So this is basically the agent itself trying to determine what are the steps that I need to do. And this is all designed by a library called LangChain. That's an important library that is used for this example. And with this library, we created a custom agent and a custom tool that's called CW tool. The CW stands for CloudWatch, and this tool does exactly what the name implies. It communicates with AWS CloudWatch service, it runs query, and then it retrieves data. And you can use it outside of the AI. But with this integration, the AI agent can actually use it as well. Because this AI agent has access to this tool, it will also determine that this is the right tool to be used. So you can see in the action, it says CloudWatch. Well, this is interesting, right? Now the agent is communicating to an external tool and passing it certain parameters. What it's passing is, hey, search for IP addresses used by the admin. So this is the output of the tool itself now, right? Within the same command line. And you can see that the tool is pre-configured with parameters that allows its access. So for example, it has access to these log groups, so CloudTrail VPC flow. It also has a bunch of other configuration, including which model the tool should use. And in this case, GPT-4. Just to kind of demonstrate that there are multiple models that we can use, and Abdul will talk more about that. So the tool is doing the search, and it needs GPT because it needs to translate the request, which is search for IP address used by user, into an actual CloudWatch search query that can actually work. So fields, timestamp, filter based on the username being added, and the source IP address, because I need to see the source IP addresses too. Now, this is an important piece here because this needs to be very, very accurate. If this was not, this would not work with the AWS APIs. You can also see that the CloudWatch search is running because it needs some time, and you can see the results coming back in a JSON format. Now, this is interesting. This result is coming to the tool, to the CW tool, and it is being passed to the agent itself. In purple, you can see the observation that says this and that. This is the JSON. And then the final step is for the agents to read this output and make sense of it and basically give us the final answer, which is these are the IP addresses that are being used by the admin. So this is a testing example to demonstrate how agents work with tools. This is a very big topic. And again, we will give more practical examples as we go. Now, the last piece that I want to talk about is how do we enrich data, right? And this is where embeddings come into place. And if we are to simplify what embeddings is, this is a way for us to get documentations. In our case, it will be an AWS documentations. And we're going to create numeric values for them using a special AI API so that we can search through these. So that if you go to the model and you say, hey, can you tell me how to create a VPC? You can do that with ChatGPT now, but if something changes on the AWS, it wouldn't know the new answers. With this method, you can utilize agents and tools. So there will be a tool that will basically access this database of documentations, and it will get you the answer from the latest documentation. There are other use use cases for embeddings, we are using the search mechanism. But I wanted to point out these because one of them says anomaly detection. That could be very interesting in the future for us in detecting specific behavior. Now, with that, we all understand privacy, right? So I would like to just remind us that these are AI models that are hosted somewhere else. These are public-based models. We could have our own internal ones, right? These are local ones. If we are to use the public ones, we need to be aware of the provider's policy. What are they doing with our queries? Are they using that for training, etc.? We should also be aware of the compliance framework that we rely on. If we have to adhere to HIPAA or any other compliance. And then finally, if we have to use a public model, we can always use data masking. This turns out to be a lot of work though, because we have to be very, very careful with it. And at the end, it's the best way to guarantee privacy is basically use local models that we control. But that is a different topic. The last thing that I would like to share with you here, and this is not about security, but I felt like we have to introduce this slide. And this basically shows us that even though this entire AI is new, OWASP, for example, already has a top 10 security concerns or considerations for large language models. Now, with that, I will move it to Abdul to share his experience by taking these concepts and actually applying them into real life. With that, Abdul, it's all yours. You are muted.
Sorry about that. Thanks, Ahmed. Yeah, I'm excited to share our experience in building AI into our application, and I'm hoping that out of this, you can take some ideas if you want to build your own applications internally, or if you have a product. It could be small use cases, or it could be even larger ones. So with that, I'll just give a quick introduction of our ASecureCloud. So ASecureCloud is a software platform. The idea is that we wanted to remove all the heavy lifting from building and operating cloud environments. So we do that by giving you a dynamic configuration library. So if you want to build something and you want to make sure it's secure, you don't have to be an expert. You can come to the site, browse through the library, pick out the things that you would like to build. It'll be generated for you, and then you deploy it. And then we combine that with continuous compliance and monitoring, similar to other CSPM tools out there. However, in the last, or in this year, so we started introducing this new AI-powered advisor, and that's what we really want to talk about. Cloud Advisor is basically an assistant that combines the knowledge of the latest in AWS. So it knows officially what's out there in AWS. It's constantly being updated on that. Plus, it's aware of your own cloud environment. So it's kind of an all-knowing cloud advisor that's tailored to you, aware of your context and what you're building with. And you can ask stuff like general questions about AWS, like how do I monitor root activity in my account? You can ask it stuff about your own environment, like do I have anything that's internet accessible? Do I have anything that is not encrypted? Or you can ask it to help you build stuff, like can you help me build a network with some private subnets so I can host my databases. So some of the results that we've seen so far with this approach, and these are early. This is something that we started around March, April, so it's still very early. But from a product development, we've been able to expand the coverage because we're using the AI as well as in building the application itself. So we went from about covering 50 AWS services that we had in our configuration library to now all 200 plus AWS services. But the more interesting part is the user experience highlight. So before, when we were giving users reports, they usually security administrators or security consultants who are going through these reports and taking out the information that are relevant for them. But now with the AI, especially with the natural language capabilities, you can do stuff like, do I have any users without MFA? So you can just quickly get to the answer. The other more interesting thing that we've also noticed is that it's letting less technical users access the same reports and access the same tools. And because it's using natural language, you can ask at your own level, at your own comfort, how however you would like to get that information. And that's letting people who are more like in a manager position or a VP position access the same reports and ask stuff about their compliance status and encryption and these things. So let me share first how we built that trusted knowledge base. So as Ahmed mentioned, there is a process of enriching the AI or the LLM with more current sources of knowledge. So the first thing that we had to do is make sure that the AI that we have has access to the latest trusted documentation sources. And we do that by selecting things like official AWS documentations, knowledge center that is stamped by AWS, and so on. And we have a process to continuously update that and monitor those documents as they change and adjust them. But then when a user searches for a question or inputs a query into the AI, we need to find the relevant documents for that question or query. And that comes back to the topic that Ahmed introduced, which is embeddings. Embeddings basically gives you a semantic or a meaning representation of the documents in the query and find similar documents with the meaning to what the user has asked. However, we found it to be not totally fully accurate. We had to kind of augment it with keyword search. So that's a traditional keyword search that you're probably familiar with from like putting something on Google or like a regular database. And that increased accuracy, especially because in technical settings, like in the settings that we are working with, sometimes you're not really looking for the meaning, but you're looking for like a keyword match. So if you're asking something like, what is drop invalid header fields? The embeddings or the AI way of doing this is try to find the meaning of that drop invalid header fields and find documents that match something similar to that meaning. But in our case, we need to find the exact match of that keyword because that's a technical term that we're searching. So combining both the traditional way of doing search with keywords and a new way from AI with embeddings and semantic search has proven to be the best way to do that. And the way this looks in an application, and you can think of this in internal applications that you can build or augment things that you already have or are using right now. But what it allowed us to do is make security reports an interactive experience. If I'm giving a recommendation like the one that you see on the right side, you can have the user ask their own questions back to the report or the finding. This saves you time, this saves the user time, but also saves you as an engineer or a support person or a consultant from all of those like first level support questions. And the way this looks, I'm just going to show like a quick demo here of that same feature. But basically, we're providing a feature here recommendation saying you should enable, for example, guard duty S3 protection for your S3 buckets in the account. The user in this case read through this overview, understands what it is, but might have a question like, how much will this cost me? So it's a common question that they can ask. So this will take it back to the AI. It will bring in a summary of the cost for that. It will give them some more references where they can look that up further and gives them the option to as well ask any follow-up questions. So that's a question that might have come to you as the security person in the organization or as a consultant that you can now kind of offload and be more worried about like higher things. So the other thing that we also learned here is that there's a lot of available models out there. Like Ahmed mentioned, OpenAI has multiple models out there. There's other companies like Anthropic that has their own models. There's a lot of local models, especially with the Llama 2 that you probably all heard of in the last few weeks. So the idea is that you want to evaluate the different models based on speed, accuracy, cost, all of those things. And then you don't have to stick with one model for solving a specific problem. You can mix and match and include multiple models and multiple calls in the same query. So this is an example of how we implemented it. And again, this is something that you can like think about how you can implement in a local context as well. So this is a question a user can put in. Do I have any instances that are not encrypted? And the answer comes back saying something like, yes, you have 7 instances in the environment that match this, and we can give you a list of those unencrypted instances. So we're giving you here a summary of that. And then you can go through the summary and review those instances and so on. The way this works in the background is we're using, in this case, two models, both from OpenAI, but both with different capabilities and different price points. When the user puts in their request, it's a natural language request, and the first thing we need to do from the AI's perspective is translate that into a format that we understand. Take out the keywords in that natural language query and see how we can use it into searching our application, our database. So in this case, it says, do I have any EC2 instances? Not encrypted. So we're translating that into the AWS services EC2, the resources instance, and then here's the filter, encryption is false. We can take this query and then search our database, and then take that result and summarize it. So we say, like, there are 7 matches with these properties. Now we can display this back to the user as a table, and that's how traditional interfaces work. But because we have that natural language capability, what we can do is have the AI again summarize that result and make it a little interactive and more natural. So we can add something like, there are 7 EC2 instances in your environment that are not encrypted. And it gives you the feel that it's like a little bit more conversational than just a question and kind of results. In the second part, we're using a less capable model because it's cheaper, it's good at summarization, it's good at that part, and we don't need that high level of accuracy that we needed at this first part where we needed to go and search the database. The other thing that kind of becomes clear as well as you start building with AI is you don't want to rely on it for everything. So you don't want to overutilize it. In that previous example that I showed, we could imagine a scenario where we put all the data in the AI and ask the AI to find the 7 instances or the instances without encryption. But we don't need to do that because we already have a database. We already have a proven method of searching through the database. It's reliable, it's quick, and it's cheaper. So don't need to kind of put everything into the AI. But instead, you want to use what the AI models are good at. So there are multiple models, different kind of use cases, but a lot of times if you want to use them for kind of knowledge answering, classification, summarization, code generation, those are the kind of things that they are very good at. The other important layer that you want to also think about, especially if you're creating an application that you're making available to your users, whether they're internal in your company or external, is you want to add a layer of validation. The models themselves, as you probably know, are probabilistic, and if you use ChatGPT, you know that it can give you some results that are not as accurate. So it is possible that you can produce errors. You can do a lot of fine-tuning, you can do a lot of augmentation, like Ahmed mentioned, that reduces those errors, but you still want to add an independent validation layer to make sure that the output at the end lets you, or you're sure that it's safe and it's correct. So for example, if you're generating JSON data, you can add a JSON linter at the end that just evaluates, is this JSON good or bad? And the good thing is that you can send that result back to the AI if it's incorrect and have the AI correct itself. It is very, very good at that. This is an example of how we thought about it at ASecureCloud. Is, for example, when we're creating those infrastructure as code templates, we're generating them with the AI, we put a lot of guidance, we do a lot of training to make sure that it's accurate, but still errors can occur. And sometimes it's not the LLM itself or the AI, it's sometimes the user has put in some bad input. In this case, for example, they've put in a bucket name that has an exclamation mark. The AI couldn't know that or didn't know that that has an issue. It still generated a template with. So at the end, we present a validation result using a tool from AWS called CFNLint that can go through the CloudFormation template and give you kind of a check or a fail for that and give you a point to where those issues are. So that's another thing that you want to think about when you're building applications on your side. One of the other things that we've also thought about, and this is something that's continuously evolving for us, and I'm sure for everybody else in the field, is the experience or the user experience when interacting with the AI. A lot of the examples that you've seen right now, and you see them in a lot of the applications that are coming now, is a chat-like experience. And that's understandable. One of the things that popularized this is ChatGPT. So I think that kind of like set the way for a lot of applications. But when you're building something for your own users, again, internally or externally, it's important to understand like how are they going to interact with this? Is chat the optimal experience, or could it add more complexity in certain times? It definitely adds some ease of use because you can express yourself naturally, but sometimes it can slow you down. And this is an example of how we also thought about it as well. So in our experience, when you're generating code templates, so you can generate code templates by describing them through chat. The code template can be a big template of like 50 to 100 lines or even more. If you want to modify just one line in that, you don't want to send that all back to the AI and have it regenerate the whole thing from scratch. Sometimes giving the users a form-like interface where they can toggle stuff, where they can input stuff, is a much faster experience. So I'll just show you how this looks and give you some inspiration as well. So what you can see here is an input saying create a VPC with 2 subnets. So it's a new network, 2 subnets without any other input. The AI is going to take this and it's creating a template here. And what you see on the right side is the template being generated. And then on the left side, you see a form with the values that were inputted or used in that template. And now the user can go in and start editing those values directly. So they don't need to kind of like send back to the UI and say, change the subnet or side or block. So they're editing it here, it's changing on the right side, and the template being updated in real time. They can also add other resources. So if they've added a network, now they want to add, for example, an instance, an EC2 instance. This is added right away if they want to add a KMS key for encryption. Now, let's say they've added all of this, but now they want to make a different update, which is put that instance in one of the subnets and use the key for encrypting the instance. You can do this yourself. You can go and toggle all the right options and all of that, but maybe you just don't know which are the right options to do it. So you can go back to the chat interface and explain what you would like to do. And with those instructions, now the AI can take the resources that they've added and update the template with all the new values that were created. One of the final things that I also want to cover and also mention and discuss is logging and monitoring. So obviously, if you're building an application, especially if it's in production, you want to have some sort of logging. Usually it's used for debugging errors or things like that. With AI applications, there are also other use cases that emerge with logging and monitoring. One of the things that we see is with AI models, especially in the field right now, there's a lot of updates. It's happening every week or two. There's a new model coming up. There's updates to existing models, and you're constantly updating what you're using. This can sometimes change or impact the accuracy of your own application. So having a logging layer can kind of ensure consistency. You can monitor when things can go awry or something like that. The other thing that you can use the logging for is data for further training. If you're doing some fine-tuning afterwards, you can take a lot of examples where the AI produced wrong outputs or produced right outputs for further training. There are a few projects out there. One of the ones that we've been using is called Langsmith. It's still in beta, but it's really good, and it gives you an output like this. For example, in the example that I showed a little bit earlier, you can see here how it's broken down by different calls, and you can see the different calls and latencies because we're using different models. And you can see like one of them is almost 27 seconds it took for the call to complete, and the rest are faster models, maybe a little bit less accurate, but we can add those like independent validation for those and so on, and that's why they complete faster. But this allows us to kind of go back and track how our application is doing and take that data, and in the future, if we need to, we can do further training using some of these examples and see how our users are actually interacting with it. Ahmed mentioned security at the end of his section, and I'll also mention a little bit as well here. So one of the things that we're also starting to play with and introduce are guardrails for LLMs in production. And one of the projects that's very interesting is called NeMo by NVIDIA. And the idea is that you add this layer of a guardrail or rules between your chatbot and your users. It's constantly evaluating what the users are prompting or querying your chatbot. It has a bunch of rules that you define. So you can define things like you only answer questions about AWS cloud security, or you only answer questions about my own environment. And you can define things what it shouldn't answer. So you can say, like, don't answer things about politics or shopping or things like that. And it uses the AI itself to determine, like, is the query from the user coming in, is it about politics or is it about AWS security? And if it is about politics, it goes back to your rules and then prompts the user something like, I'm only here to answer AWS security questions. I don't want to talk about politics, for example, and try to redirect the flow of the conversation. This obviously makes the product better, but also can help with things like people trying to kind of like do a prompt injection and jailbreak out of it. It's definitely an interesting kind of project that's used. With that, we added some links for further reading, some tutorials to get started on a lot of the topics that we added. I also would encourage you to try out the Cloud Advisor. It's freely available on our website, asecure.cloud/AI-Cloud Advisor. And if you have any feedbacks or any questions, just send them to us as well. We always appreciate that. With that, Ahmed, I will give it back to you.
Thank you, everyone. Before I talk about this slide, just like a few comments. Thank you, Abdul, for sharing all this. Just to iterate again, the reason why we are talking about this early on is because these applications are new, and with them, there will be a lot of security risks and issues that we have to deal with. And it's better for us to learn about these new technologies early on. We do not fully understand the implications yet, but this is moving very fast. And if you compare it to cloud, where like it took us a few years to kind of understand what these risks are going to be, this is much faster, and it's not going to take us a few years to basically understand those risks. With that, finally, I would like to point you out to the cloud curriculum, to the SANS cloud curriculum. The class that I teach is SEC 540. That's the cloud security, DevOps, and automation. And SANS has a fleet of cloud security services. Feel free to go to the SANS website and follow us on Twitter and LinkedIn for updates on that. With that, let me see if we have questions.
We have no open questions at this time. We can give it a minute or two and see if folks drop questions in.
I did see one question earlier about linting. Abdul, do you mind telling us a little bit more about that? So you did mention in your presentation that you do linting using CFN lint and other technologies. Is there anything more that you can share with us about that process? You are on mute.
Sorry about that. So let me just go back to that slide. Yeah, so basically for us, we use linting in a couple of places, actually, not just in this one. But the main idea is that whatever output that you have from the AI, you want to try to find an independent way to validate that output, whatever it is. And that could be another AI that evaluates it. Like if you're giving an answer, for example, you can have another AI evaluate, is this accurate or is this not accurate? So having that extra layer helps. If you have something that is kind of like code-based, that is, let's say, JSON or YAML, there are existing tools out there that can just, it's basically small libraries that can look at the syntax and tell you if there's any issues, spot any problems like that. In our case, we use the CloudFormation lint because we're generating infrastructure as code. But you can imagine, for example, if you're generating Python code or Node.js code, you can put that through a syntax evaluator and make sure that whatever the output is accurate or valid. But that's really the main idea.
Terrific. And in that time, we got some more questions. Can you please give more practical examples where Cloud Advisor can be used in day-to-day tasks?
Yeah, I mean, the main idea is that it was built, or we are building it so that it's being used. It's used for day-to-day tasks. The main things that you can do with it are you can ask about anything that you have a question about AWS, and so instead of having to like do a Google search, sift through documentation, and find a relevant answer, you can ask it stuff like, how do I enable encryption on this, or how do I disable monitoring on this thing? And the idea is that because we've connected it to your environment in a more private way, so it's not actually asked, like, I can talk a little bit about that later, about our philosophy in that. But we can, when you're asking a question about how do I enable encryption, it also has the context of what is already encrypted in your environment. So it can use that information as well to kind of enhance that. So it can say to you, you can enable encryption with these settings. In your environment, you don't have anything that is unencrypted, so you're good. But here's the information. Or in your environment, you have these three S3 buckets that are non-encrypted, and this is how I would recommend it from these options. And this is something that will evolve over time as we continue to build it. The other major thing that we also are focusing on is like what you see on this slide is the building of configuration. When you want to say something like, I want to build a new EC2 instance or a web server in my environment, you want it to be able to take what is already existing in your environment into context. So it's not just giving you a static template to say, here is a template to build a web server. It's going to say something like, you already have a network. Do you want to put that in the existing network or existing VPC, or do you want to also include a new network and a new VPC? So it kind of have that interactive interaction with it. And that's what building with AI or an LLM will allow us to do.
Wonderful. And a follow-up question to that is, do you plan on implementing it with other cloud providers?
Yeah, that's a very good question. We do have plans for Azure next, but the idea is that we want to get the experience right first on AWS. It's a lot of moving parts. We're learning a lot, we're iterating a lot. So nailing that experience first on one cloud provider is a much easier way before branching off. And we do have plans at the end of the year to introduce Azure as well.
Terrific. Next question. What is the best strategy or tools to digest documents for the training models?
That's a very good question. And if you do a search online, you'll find a lot of different libraries and services out there to do that for you. So LangChain, for example, Ahmed mentioned LangChain. They have their own library, actually a bunch of libraries for ingesting all types of documents from all types of formats, like PDFs, websites, even videos and audio and stuff like that. There are a bunch of other libraries that you can like find as well. But to be honest, in our internal implementation, what we found is that we needed to do our own document ingestion implementation. And that's because we know the specific documentation that we're working with. We're working with official documentation from AWS, mostly knowledge base articles and stuff like that. So we know the format for these, and we can architect our ingestion algorithm to kind of break the documents in a way that keeps the context and the meaning. That's one of the main kind of like pains about this, is that when you're ingesting these documents, you want to break them into smaller parts, because a lot of these AIs cannot ingest thousands of documents at once. So you want to make them a little bit smaller. And sometimes when making them smaller, you lose like the bigger context. You're taking just paragraphs out of a page. So that process is still evolving, like everything else that we're doing. But we have we found a kind of a happy balance of building our own and implementing it. But if you were starting right now, I would suggest using one of the libraries out there. LangChain is a really good one. And then just seeing where it fails or where it's not as accurate, and then start tweaking it then.
So I have a follow-up question actually on that note. So you mentioned that we need to break the documents so that, because the LLM models have limitations. Can you talk a little bit more about that? So does that mean that you're having a big documentation, you're taking a chunk of it, you're sending that to the LLM model, and then you're basically asking it questions related to that piece?
Yeah, that's exactly it. The LLMs, they have what they call context window or context window size. And that's how much you can include in your request or in your query. So if I'm asking a question of how do I encrypt an S3 bucket, I can send it, for example, a few pages, but those pages cannot be longer than, depending on the model, sometimes it's 4,000 tokens, so like approximately 4,000 words, 8,000, 16,000. So every model has a bigger or smaller context window. And obviously there's also a cost component to it. The more words that you include in your query, the more that you are spending. So you are incentivized to make it smaller, to only include the things that are more relevant. So having a way to ingest those documents, break them up in a way that keeps the meaning, and then an algorithm for retrieving the ones that are more relevant is very important.
Terrific. And we have no more questions at this time. So thank you both for your time and your expertise and sharing your knowledge with us on this hot topic of AI. We will look forward to more content from you guys to share with the community in the future as well. For those who are listening in, thank you for giving us your time, and we look forward to seeing you on another SANS webcast in the near future.
Thank you, everyone. Thank you, Lara. Thank you, Abdul. Have a great day.
Thank you very much. Thank you.